N2 and so on. For that reason, I don't know why, but I know that it's just halogens. So in this case, halogens is group 17. So group 17 should be here, around here. So that means the answer is element F, I guess.
Correct. Correct, correct. So far A and B is correct.
So now, the next question, they ask why is element B unreactive? Element B is a part of group 18. Group 18 are the noble gases. Navin, can you take over the wheel?
So since it's noble gases, it has 8 valence electrons. So it has already achieved stable octet electron arrangement. So when you want to write your answer, you write element B has achieved stable octet electron arrangement.
Actually, teacher would prefer you say the word atom and not element here.
Okay, sorry.
Okay? Try not to use the word element if possible. Okay? Fahmi, cancel the word element, put the word atom. Okay. So far, yes, correct. All 3 answers are correct. Okay, atom B. Okay, so can you all mark the answers together with them?
Okay.
Okay. Carry on, Fahmi, or Navin.
Now, a sec. So the next question they asked about atom E, which is over here. So they asked for the electron arrangement. The electron arrangement for atom E can be determined by its position at the periodic table. So in this case, atom E is in group 15, I think. I don't know.
Don't know. Apa punya cikgu ni?
15.
Group 15 and period 3. So since it's in group 15, it should have 5 valence electrons. And since it's in period 3, it should have 3 shells completely filled with electrons.
Correct.
So that means the electron arrangement should be 2.8.5. Since it's from group 15, which all of it has a total of 5 valence electrons each, and it's in period 3, where it has 3 shells. And then they asked for the position of element E in the periodic table. I just said it has 3 shells filled with electrons, so it's in period 3. And since it has 5 valence electrons, it's in group 15.
For me,
Yeah?
so do I put group first or period first? Which is the correct?
I don't think it matters. Unless it does. Che, does it matter, Che?
It doesn't matter at all.
Oh, okay.
Thank you, Che.
No worries.
Thank you, Fahmi.
Thank teacher lah.
Okay. Okay, what if Fahmi's question, but Fahmi gave the answer already. What if it's a 3 mark or a 4 mark answer? Okay?
Oh.
What if it's a 4 mark? Fahmi, go back to your previous question. Okay. Fahmi, call out some people, Fahmi. Don't answer everything for them.
Alif, come here.
Why me,
Alif, you have to understand. It's just business.
Oh, yes. How may I help you?
So teacher just asked, right? What if question 2 was a 3 marker? How would you answer it?
4 marker.
4 marker.
Yeah,
Wow,
I'm sorry,
even
Che.
harder.
I'm not sure.
Fahmi just gave the answer actually, you know.
Oh, that one.
Oh, so I get it. So you have to state that atom E has 3 shells and atom E has 5 valence electrons.
Correct. Yeah. So Fahmi, write down. If it's a 4 mark answer, okay, everyone writing down in your paper as well. Everyone, it can come out in essay and has come out many times. Okay. Atom E has 3 shells, occupied or filled, it doesn't matter, with electrons. And if for group 15, it has 5 valence. Atom E has 5 valence electron. Not number of valence electron, 5 valence electron. Is everybody clear about that?
Yes, sir.
Okay, go on.
Sec. Okay. So this is the next question. They say which element has the above characteristics? It forms a colored compound and it acts as a catalyst. So a colored compound comes from a transition element. So we can rule out all these other parts out, all these other elements out, because they're not part of the center. This part, this entire part. This is where most of the transition elements reside, over at this middle part. So there's only one which is H. I think it's because H is supposed to be iron, which is a catalyst in vanadium.
Okay, you don't need to know exactly what it is, but they just want you to say which one is a transition element.
Okay, thank you, Chair. So next question, they ask. Next, Navin, can you take care of this question?
So the next part of it, they ask to name like the group of it. So since it's in the middle area, it's called transition metals.
Transition metals.
Actually, transition elements.
Elements, yeah.
Yeah, Navin, transition elements is better.
Oh, okay.
Okay, all right.
Okay, thank you, Chair. So that's all the questions. Do you have any questions?
Who's going to do F?
Oh, F. I forgot about F.
For me,
Yeah?
if I just write transition element, no S, is my answer still valid?
I don't think so, because I remember I wrote alkali metal as an element group and it was wrong. So I'm guessing if you wrote transition element, I don't think it's going to be right.
Okay.
Unless if it's actually right. Teacher,
No,
is
no,
it right or-
you must have transition elements, yeah? Must have the S.
Okay. Thank you, sir.
Okay.
Teacher. So G reacts with F to form a white solid compound. State the type of compound and the chemical formula. So G is over on group 1 and F is over on group 17. So group 1 has 1 valence electron and group 17, not 7, has 7 valence electrons. So that means that the charge of G would be 1 plus and the charge for F would be 1 minus. So if you combine them together, usually what you would do is that you trade amongst the numbers, but in this case it's not necessary since their charges practically go against each other. So what you would get is G and F. F, that's an E, F. So now they also ask what's the type of compound formed. G, group 1, is alkaline metals. So that means that G is a metal and F is a halogen. So that means it's a non-metal. So metal and non-metal creates ionic compounds. Therefore, GF is an ionic compound.
Correct. Wonderful. Okay, so anything else, Fahmi, you want to add on?
I don't think so, no.
Okay, so Navin and Fahmi, both of you, good job. Well done for question number 1. Easy and simple explanation. Anyone else who wants to say anything to them? Okay, if not, can we give them a round of applause, please? However possible that you can do that. Okay, thank you, Fahmi and Naveen. Okay, can I move on now to question number 2? I think it is Sayep and Mio, kan?
Yeah, sir.
Okay. Okay, while we are waiting for Mio, maybe just one comment, positive comment for Naveen and... Okay, never mind. We'll save it for later.
Okay, Sayep, you want to start first?
How do I write that?
Okay, I'll write the equation.
Okay, I want to just encourage you teachers. Okay, Yu Hong is in. Don't answer everything on your own. Try to get the participation of your wonderful students who are listening to you. That will be the best thing that you can do when you share.
Okay, actually,
Can Mio?
wait, sir. Yeah.
Okay, so while we wait for Mio, maybe he's just doing. Okay, one positive comment for Naveen and Fahmi's work just now. Positive, yeah?
Fahmi's handwriting was nice.
Okay, thank you very much, Fahmi and
Thank you.
yeah, Fahmi and Naveen. Okay, how about your presentation?
I like
Well
it.
constructed.
Simple.
Well, construction is smooth.
Okay, good job. Okay, anyone else? Can put in the comments. Actually, this will boost them. So think about helping them. Actually, you put in the comments, be very nice. Put in the chat group. Okay, put one thing that you appreciate about their lesson just now. If you said it just now, okay, put it in the chat. Remember when it comes...
I never heard Fahmi teach before, like, so this first time teaching is very...
Yeah, that's
very
right.
good.
Put it in the chat. Put it in the chat. So it'll be good for them. Then they read, they'll be happy. Okay, good. I see some people chatting already. Okay, good. Right? So at least when they read, you see, you boost people's confidence when you write all this. Okay? Okay, Mio, are you ready?
Yeah, sir. Okay, Sayep, you're starting first,
Okay,
right?
so morning everyone. So basically question number 2 is
Shape telling what shape talking cannot hear.
Say it louder, say it.
okay, everyone can hear me now? No,
Yes,
you're so
yes.
soft.
Can you make yourself louder a bit?
This is the loud.
Huh?
Shout. Maybe you should shout.
Okay, so basically question number 2. Is it okay now? Louder would be nice. How loud do you want me to go?
Go to the
Because very soft, bro.
go to the speaker. Speak into the speaker.
Do you have a microphone, like your earphone?
Okay, can you hear me now?
Yes, perfect.
That's a
Yeah,
bit
better.
Thanks.
Good job, Sayep.
Yeah.
Thanks.
Sayep?
Can you hear me now? Hello. Yeah. Okay. So basically, question number 2 is about potassium reacts with water to form an alkaline and a colorless gas. So we know that the colorless gas is hydrogen gas. So it's basically a straightforward question. So your answer would be for X. To balance the equation, you just put X would be, let me out, I'll take over.
Okay.
So it'll be 2. Yeah, I will just write here first. Y would be 2 and Z would be 2. Okay, so it's quite easy. So basically it's just 2 here, 2 here, and 2 here. Okay, any questions for part A?
Oh, understood.
So going on to B, they ask name the reactants and the products in the chemical equation above. So question number 2 is very kind enough to give the whole equation up there. So basically reactants are anything before the arrow. So wait, so this is your reactant. This is your reactant, and this will be after the arrow will be your product. Okay, so let me write down the answer. Okay, so for reactant, I write short form reactant. You have to write in full, which is potassium. Potassium and water, H2O, which you cannot write in chemical formula, you have to write in full. Where am I going? Yeah.
Can I say potassium metal?
Sorry?
Potassium metal for the reactant. Potassium metal and water molecule.
No, you can't.
Why?
Because they asked the reactant based on the equation. So it's only written there as K, so you have to put as potassium.
Okay. Oh, okay.
So your product will be anything after the arrow, which is potassium hydroxide. And hydrogen gas. Okay. Any questions?
Understood.
No questions?
No, I
Okay.
think there are no questions. We can go on. Okay, the word, yeah.
Just want to double confirm because I'm a bit confused here. So for my reactants and product, I put potassium metal. This for reactant first, potassium metal and water molecule. For my product, I say potassium hydroxide solution and hydrogen gas.
Okay, you will not get wrong for it, but I think it's unnecessary.
I think you can get WCR.
No, he's not going to get WCR. Why he wants to get WCR? The
Not
potassium.
sure. I mean, he might. Sure, he might. If he did that, he might.
Why?
Could.
Because
if he accidentally wrote like potassium, like I don't know, potassium plastic, he could get WCR. Could.
Potassium plus what?
Never mind, Che, never mind. never mind.
He didn't put K, he's putting potassium metal. Okay, you wouldn't get wrong, but Bhuvanesh, answer the question. They're asking for name the reactant. So no need to have metal and molecules and all that.
Okay.
Not necessary. Okay, for me, I would say it's not necessary. Depends on the marking scheme on that year. Okay, all right, go on, carry on.
Thank you, Chair. Thank you, sir.
Okay, so for question C, wait. I'll just write back the region. Okay, so for question C, it asks, interpret the above chemical equation quantitatively. So when you ask like that, you have to look at the numbers in the equation. So as you can see, for potassium, it's 2. For water, it's 2. For potassium hydroxide, it's 2. And for hydrogen gas, it's, 1. So from this, we can see that 2 moles of potassium reacts with 2 moles of water to produce 2 moles of potassium hydroxide and 1 mole of hydrogen gas. So I think this one is pretty simple because they already give the equation. So does anyone have any questions?
No.
It's quite simple.
Okay,
They shouldn't have given the question. Too easy.
Can I say produces? I see produce itself, right?
Where?
2 moles of potassium and 2 moles of water produces 2 moles of potassium hydroxide and 1 mole of hydrogen gas.
I think you have to say reacts because you are just saying the two things, then
Oh,
you're not saying
yeah.
it's in a reaction.
Yeah, thanks.
So you have to have the word reacts and you have to make sure it produces both these.
And one more thing, yeah, the word reacts, you cannot use the word combine. Please make sure. Okay, you
Yes,
must
yes.
use the word react, cannot use the word combine. Combine is rejected. Okay, good. Next one.
Okay, so for D, normally some people can get confused with this, but if you write down the formula, it should be simple enough. So calculate the mass of potassium needed to release 50 cm cube of hydrogen gas at room condition. So they're asking you to find the mass of potassium and they've given you the volume of hydrogen gas. So normally even before they ask anything, normally I straight away, as soon as I given the volume, I try to find the mole. So they already give that the gas occupies 24 decimeter cube per mole at room condition. So you already know that the mole of hydrogen gas equals to 50 over 24. But remember that the volume is given in cm cube while the standard room temperature is given at decimeter. So remember to convert from centimeter to decimeter. The easy way I like to remember it is that because in the alphabet A, B, C, D, so since D comes after C, D is bigger than C. So just remember that every time C goes to D, you have to divide by 1000. So 50 divided by 1000, you get 0.0. Okay. 1, 2, 3.
Oi, mathematics.
Sorry, I did it straight away in my calculations. But either way, the whole thing divided by 24, you will get 0.002 moles.
Right.
So this is why you need to balance the equation beforehand, because you can see that there's only 1 mole of hydrogen gas while there's 2 moles of potassium being used. So always remember to compare by putting 2 moles of potassium, you get 1 mole of H2. So if the H2 is 0.02, then you just times it by 2 because the ratio is 2 to 1. So you get 0.04. Remember to write the full thing because I'm just doing this because it's faster. So when you you already have the mole, and they are kind enough to give you the relative atomic mass of the potassium. So remember the formula that mass over molar mass equals to mole. So since we already have the molar mass, which is 39, and we already have the mole, which is 0.004, so you're trying to find the mass now. So just remember that basic maths, if you have the bottom and you have the equation, the answer, you just times each other to get m. So m equals to 0.004 times 39, which you get the mass is 0.156. But remember to always put your units. So if you answer this alone, it's wrong. Remember to put grams. Any questions?
So I
Very-
understood.
Anyone else has a question? Okay, don't have. I think both of you all presented also very well. Very good explanations, easy to understand. Okay, once again, put in the chat group how you felt their presentation was. Good job, everybody. Clap hand, Mio, for me, for Sayep and Mio. Well done. Okay, good job, both of you. All right. Let's go to question number 3. Put in the put in the chat group. Put in the chat, okay, how you feel about their presentation. Again, now we are helping one another, okay, all right, to help them to boost their confidence. Okay, question number 3, Jason and Yu Hong. Jason, did you need me to share my screen or can you do it yourself?
Yeah, I can do it.
Okay, good. Handsome, Adam. Oh my goodness. All right. Okay, let's go on to Jason and Botak. So far, okay or not? Do you all understand each another's explanation?
Yeah.
Just to let you all know, right? I'm recording this, yeah? So it goes on YouTube.
Oh.
Okay, Jason, can start?
Sure. So we are going to talk about the third question. So yeah, come Botak will explain for you guys.
Okay. A1 suggests a suitable electrolyte for the experiments above. So for me, I will just electrolyte is a molten or aqueous solution. So we just need to choose any ionic compound that is molten or aqueous state. So for me, I choose sodium chloride solution.
Okay, perfect. Good. Must have the word solution. Teacher wants to see the word solution. Whatever you do, must have solution. Okay, go on.
Okay, for the next is the arrange metal P, Q, R, S, and T in descending order in the electrochemical series. Okay, so negative terminal must be on top, positive must be below. Potential difference greater, the distance will be further apart. So for here, the answer is PQRST.
Okay. Wait. Anyone has a different answer than PQRST?
Yes.
Anyone else?
Okay, now I write how I do this lah. Okay. Okay, for P and Q, the potential difference is 0.7 and the negative terminal is Q. So Q is in front of P.
Okay, correct. Must try to write faster a bit, okay? If you can.
Okay.
Yeah, so this is the first one, the P and Q. The negative will be on top. Then we'll go to the second column, which is P and R. It says R is the negative on top. So R is on top of P, and it's greater than the first pair of metal. So you'll still be on top of Q. And the third, it says S and Q, and S is the negative. Negative will be on top. So S and Q, S will be on top. So will be on here. Oops. Okay. And the last pair is T and S. Well, T is negative, T and on top, so it's on top of S. So it'll be here. And you will see that S and Q, sorry, P and R will be, yeah, so it says from the descending order, so it's from bottom to top. What I get is from the question, so bottom will be P, Q, R, S, T.
Wrong. Descending order must be from top to bottom.
Oh yeah, that's the part I confused.
Okay. Never mind, but it's good. Your explanation was very good. Your answer is wrong. Can you terbalikkan your answer so that everybody will know?
Yeah.
Good job, guys. It's okay. You'll make mistakes.
Okay, very good. All right. Okay, good. Next one.
So for the third question is state the pair of electrode that give highest voltage and predict the potential difference of the cell. So just now Jason already showed the highest and the lowest, and we count it and we get 2.9 volt.
Correct. Okay, yes, correct.
Okay, number 4. If metal Q is copper, suggest metal P, give a reason. So according to the formula, kalau nak kahwin mesti ada cakap fleksibel supaya perempuan hasil cukup anak. So for cukup is copper and the anak is the only thing is silver because it's below copper in the electrochemical series, or you can write because it is silver is less electropositive than copper in electrochemical series.
That was so funny to hear you say that, but very good.
Okay.
Okay, so if you go to the part D, and it's a electrolytic cell, and say is name the process carried out by the student. So yeah, there's a spoon or other metal thingy what I do usually, and with a metal electrode, and it usually will be the electroplating process.
Okay, I just want to stop here for a while. I want you to go and look at the question, question B. Diagram 3.2 shows the setup apparatus used by a student to coat an iron spoon. Whatever word appears first, that's your cathode. So that's a way for you to memorize which is my cathode, which is my anode. So coat iron spoon. So write down everybody on top of iron spoon. The word that appears first, always for electroplating, the one that appears first is your cathode. So iron spoon is your cathode with a layer of copper. Copper is my anode. So I'm giving you a hint of knowing which is my anode, which is my cathode. Okay, Jason, go on.
Okay. So the second state the energy change in the diagram. So for electrolysis, there are two answers for this, which is chemical to electrical or electrical to chemical. Both is the chemical to electrical will significant for voltaics, voltaic cell, which you will see the diagram. There are two dry cells there, so it starts from electrical energy and change to chemical energy.
Correct.
And the third, which is the half equation for anode and cathode. So anode will discharge and donate electron, and the anode, since teacher says the anode, which is copper electrode, and copper will discharge into copper 2 ion, and it donates 2 electron. And at the cathode will receive. So in the solution, there are Cu2 plus, and solution X will have another cation, which is hydrogen ion. But usually for electrolysis, we'll select the lower in the ECS. Copper 2 ion is lower, and so there at the cathode, the Cu2 plus is selectively discharged into copper atom.
Correct. Both also correct.
Yeah. So the question ends this.
Okay, well done. Again, both of y'all did a very good job so far. Number one, number two, number three, very good. Okay, easy explanations. Can I have everyone commenting in the chat, please? Okay. Everyone commenting in the chat. Good job. Good job. Very easy and understandable. Question 4, shall we get ready? Shimi and Anne, right?
Yeah, can you?
Put your link into the group so they can go there.
Okay, I just share the screen. I don't want to give the link.
Okay, no problem. If you all are writing, make sure you all write faster a bit so it doesn't take too much time.
So it ends there.
Can you enlarge your screen or not?
Okay.
Okay. All right.
Yo.
Is that very nice, the conversation going on? Okay, are you all going to talk?
Yeah, but
it's like how we text in WhatsApp and then we send the answer.
Exactly.
Share that.
Okay. Hello, Oshimi. Okay. Carry on quickly.
I don't know where and she's not on in the mic.
Oh, sorry.
Okay, go. Quick, quick, quick.
And have you done chemistry paper, feeding career paper?
Yes, but some I don't know though. Want to share knowledge? I mean, more to share answer actually.
Matthew and
Yes, I know you. You are one of Kwan Chinga's favorite students.
Okay, what?
So first thing is, I'm pretty confused. What is missing in the picture? Can you help me?
Oh, for that question, just draw stopper like this.
Oh,
There, the blue one.
so it's basically like this. Need to draw the stopper over here.
what's the
plus?
The end go?
What?
No, go ahead. Go ahead. Carry on.
Just need to draw stopper because if there is no stopper, then the gas will escape from the conical flask. And then if you draw stopper, don't. I don't know the word, tapi jangan tutup the delivery tube.
Okay, but there's another mistake here. Not say mistake, something that you must add on. Make it bigger, Hashim. Okay, can someone point out what else must they add to the stopper?
Color.
Shade.
Yeah, they must shade it. Must shade.
Oh, shade.
Any solid must be shaded. Okay, never mind. So carry on. Go on.
Oh, it's a very tiny thing and I never realized. And for question B, they're asking the equation. So the equation is Zn plus H2SO4 arrow ZnSO4 plus H2. So in this conjugation, I'm asking N. Is this? You can make an equation for question B?
Yes, it's correct.
So yeah. Finally, my equation is correct. I can give myself 2 marks.
Whoa. Okay. Now help me. I'm not sure how to do the calculation. Wait, I send you the picture. How to calculate the average rate of reaction for experiment 1 and 2?
So we make a deal that N must do the second one, I do the first one.
Yes, sir.
The way to count the average rate of reaction is the total volume of the gas released and divided by the total time taken. In this question, the total is 20. The total is 30 cm cube because we only take the time for only 30 cm cube. So the total volume of gas released is this 30. So this we need to take this 30 cm cube divided by the total time taken. As I do over here, this one for set 1, the 30 cm cube, I divided by 20 seconds, this is an S. So the answer is 1.5 cm cube per second.
Okay, that sounds easy. Let me try. So for experiment 2, it's 30 divided by 12, like this, right? So the answer is 2.5 cm cube per second, right?
Yeah, for experiment 2 is the same 30 cm cube. And the time taken for experiment 2 is just 12 seconds. So if we divide 30 divided by 12, we get 2.5 cm cube per second. Okay, for the question B, it's like they're asking that according to collision theory, what is the factor that makes difference in the rate of reaction in experiment 1 and experiment 2?
Do you realize that in experiment 2 there are catalysts?
Where? Which one?
In the question, it say copper to sulfate solution. That is the catalyst.
Oh, okay, okay. Let me answer the question. So the answer for the question is the rate of reaction in experiment 2 is higher than experiment 1. In
1 mark.
experiment,
That is 1 mark. Okay, that is 1 mark. If you have done the question, the rest of you mark yourself 1 mark. Okay, carry on.
in experiment 1, there is no catalyst, while in experiment 2, there is copper 2 sulfate acts as a catalyst. The catalyst in experiment 2 lowers the activation energy. Thus, the frequency of effective collision between H plus ions and Zn atom is higher. Thus, the rate of reaction in experiment 2 is higher than the rate of reaction in experiment 1.
Hashim,
Yeah.
can I say this? So, I mentioned the first point, which is experiment 2 has a greater rate of reaction compared to experiment 1. Then I say experiment 2 has the presence of catalyst, while experiment 1 does not have. Next is catalyst provides an alternative pathway of activation energy. More effective collision occurs, hence rate of reaction increases.
Yeah, you can see that because I think so you can say because you say about the catalyst making an alternative pathway. But did you mention with a lower activation energy?
No, I just say alternative pathway.
Yeah, that thing I think you lost your mark because you don't never mention lower activation energy.
Okay, thank you.
Bhuvanish, the frequency of effective collision, did you say between which particle and which particle?
Oh, must also mention that now.
Yeah, no particles, no marks.
Alright.
Okay, I think that day Cikgu, Mr. Ng also mentioned that, right? Yeah. Okay, I want to add on one more thing. Hashim got a bit, like what Bhuvanish said just now, you didn't mention the word alternative pathway. The catalyst in experiment 2 will provide an alternative pathway to and lowers the activation energy, so more reacting particles can collide. That's the full sentence. Are we all clear, class?
Yeah.
Okay, go ahead.
Hashim's answer is still acceptable, right?
Hashim's answer for the second point is incomplete.
Oh.
That means the sentence before thus the frequency effective collision. If my answer, it would be there is no catalyst in experiment 2. There's copper 2 sulfur. The catalyst in experiment 2 provides an alternative pathway by lowering the activation energy to allow more particles to react and collide. Because why? I must mention that because here I didn't mention frequency of collision. Can you notice? There is no frequency of collision here. Am I right?
Oh.
They go straight away to frequency of effective collision because what teacher just mentioned is the frequency of collision. You understand, class?
So must have the flow, Racha.
You must have the flow. Okay, later teacher write down the answer again. Okay, go on again, Hashim.
According to what we know, when we draw the graph for experiment 2 should be steeper than graph in experiment 1, right? Can I see your graph?
This is the graph that I draw. But can you explain about the graph?
Okay, the endpoint of the reaction is the same as the concentration number of moles in both experiments is the same. But
the graph for experiment 2 is steeper as they have catalysts, right?
Yes, you're absolutely correct.
Okay, that's all that we're supposed to do, right?
I think that's all we have to do. Let the others present their next presentation. Thank you, Panchina.
Thank you, Panchina.
Thank you, Anne and Hashim. This is so cute, yeah? Okay, so shall we give them a round of applause? Okay.
I love it.
All right. So can we have people commenting in the group? Let them.
Cute.
Okay. Better than K-drama. Pandai lah tu. Okay. All right. Romance, hello. That one too much already. Okay. Okay, can I go to question number 5? Who's doing question number 5? Question number 6, get ready, yeah?
Abu.
Okay, Abu, you ready, Abu?
Yeah, just give me a moment.
Okay.
Oh, you didn't set up yet.
Adam and Darwis, get ready. All my essay people get ready, because you'll be very fast, the essays. Are y'all marking your work as we are going along?
Yeah.
Yes, sure.
Yes.
Okay, I can't see, But what I want to do is after the class, each one of you PM me your marked work. Okay, each one of you PM teacher the marked work. Now all of you going to pretend to mark everything. Ayo, I think I know you all so well already.
Okay. Halim. So you're doing A first, right? A, B, C.
Yeah, I'm doing it.
All right.
Yeah, you put out the presentation. I got the link here for that thing.
Don't fight, boys.
No worries, you won't.
I just blocked him, but yeah.
Hi, Halim.
It's your fault. Okay, so let's start. Okay, so guys and everyone else. Today the question about good morning everyone. To our chemistry teacher Conchina, to my friends and everyone else. Today we're doing question number 5, which is salts. Thank God this is the simple version, not the complicated essay version. And they are very kind. They give us names so we don't have to break our brains. So if you see, wait, you don't know the question, is it? Because everyone has a question, right? So see on your left side, you see lead to nitrate solution. Okay, so that's a soluble salt or an insoluble salt. Which one is it? N, please answer.
I don't see anything.
Oh,
no, you guys have the paper, right? You guys have the paper, right?
Okay, my bad. I didn't hear.
Okay, so N, please answer. Is lead to nitrate solution a soluble salt or insoluble salt?
Because it's nitrate. Nitrate is soluble.
Very good.
Yes, very good. Congrats. Okay, so lead nitrate is a soluble salt. Okay, so then have number 1, and sodium carbonate. Okay, sodium carbonate is soluble salt. I can't pronounce the name. Both you better choose the name because I can't pronounce anything. Yeah.
Amirul.
Yeah.
Amirul, is sodium carbonate a soluble salt or an insoluble salt?
Soluble salt, because carbonate salts are all insoluble except for sperm salts.
Yes.
Very good. Good job.
So when you have 2 soluble salt, okay, then you put arrow, solid salt R. So if it's a precipitate, so you've got 2 soluble salt, something interesting happens. You get magic, get insoluble salt and soluble salt. But what we really care and important for us is insoluble salt. So if it's a solid, means it's a precipitate, which is an insoluble salt, right? So lead to nitrate and sodium carbonate. If you put it together, you get lead carbonate and sodium nitrate. Okay, the budak besar here is lead carbonate. Okay, lead carbonate is insoluble. That's why kita nak budak besar. Okay, kau ambil 2 budak kecil and then get budak besar. That's how you get lead carbonate. Okay, so from the lead carbonate, this question some more want to make it complicated. Ego and panaskan. So when you heat it up, you will you will decompose it, right? Am I right?
Yeah.
Okay. So once you decompose it, you get solid S and gas T. So when you heat up a carbonate salt, you get metal oxide and CO2. Yeah, you get metal oxide and CO2. So solid S is lead oxide, gas T is carbon dioxide. Okay. So now let's make things a bit more interesting. CO2, how do we want to be confirmed CO2 is actually gas T? Well, what you do is that you use a simple test. What test is it? Win, answer me. Win.
Who?
Marvin, are you there? Marvin, they are not. Marvin?
Yeah, okay. Yeah, I'm here.
How do we test the presence of CO2?
Lime water turns cloudy.
Sorry?
Lime water.
What mean?
Hello?
Yeah.
Lime water turns cloudy.
Okay, yeah, correct. Congrats. So to test the presence of CO2, use lime water. So when CO2 gas is flows inside the lime water, it turns cloudy. Okay, and how do we test the presence of lead-2 ion? If they ever ask, because this question is actually a simplified version of an essay. So I'm just giving you guys the extra tidbits. So to test the presence of lead-2 ion, what do you use? Zinc. Parma, Dante. Siap. Dante not siap. Siap. I mean lagi.
No. I'm not sure why it's here. Now I have him continue.
Okay, so to test the presence of lead-2 ion, we just use potassium iodide, simplest thing. So in potassium iodide, you add with any lead solution, you get yellow color. So you see yellow color, presence of lead. So you know lead, simple, it's easy already. Okay, so we have pretty much answered the entire, we have actually expanded everything that you normally ask in essay. Okay, so let's go for question A. Write the chemical formula of lead-2 nitrate. This is chemical formula, not the name, okay, because they give you name already. Okay, now I chill here. So to write the chemical formula is there, PbNO3 2. The two small two, not the big two there. Right? Okay. Okay. Next, name the reaction 1. As I said, this now is double decomposition or a precipitation reaction because you get a solid salt, which is what you want. Okay, that famous guy. Then B, based on diagram 5, identify salt R, solid S, and gas T. As you see this now, salt R is lead carbonate. T is carbon dioxide, solid S is lead oxide. Okay, both do C and so on.
The last one.
Wait. So for this question, you can actually put PbCO3, PbO, and CO2 because they didn't say to name. Okay, carry on.
Yeah.
All right.
Wait, C the answer was, wait, say the color of solid S. Solid S when hot is brown. Yeah, when hot is brown. Because when lead is heated, it's brown. When it's cold, it's yellow. Yes. Not
Okay.
black.
Thank you, Halim.
Both your turn. Do your work.
Halim, can you help me with the quizzes?
I'm gonna send a link, of course. I just entered, then I'm gonna send.
All right. So now, guys, sorry. Now they asked to state the color of solid S. You know that solid S, just like what Halim said, is lead-2 oxide. Let me ask you a question. What if I just letak brown? Is it correct or wrong? N. Is it wrong if I just say brown?
You got ask N already. Choose someone else.
Oh, sorry. Sorry. My fault. Go Jason. Jason. Is it correct?
I think it's wrong because it has two possible colors.
Yes, correct. In this case, being very general. So we have to state the two possibilities of colors for lead-2 oxide. So remember, when it's hot, it's brown. When yellow, it's cold. So how I remember was this year I went for a seminar. So this guy taught us this. When it's hot, so you must remember lead-2 oxide is a gangster. Okay, when hot, he gets angry and becomes brown. He takes a parang. He takes a parang. That parang becomes perang. Perang in English is brown. So that's one way. Then when it's cold drinks beer. So normally beers are yellow in color. So yellow. Cold when yellow when cold, brown when hot. Now next, they asked to draw a label diagram for heating solid R in reaction. We know this is just simple decomposition. So the most important thing is we must make sure we have our crucible, part K triangle, and triple stand last, and then one more. We have to put the solid R, and you can either put Bunsen burner, just put a normal arrow indicating it's heating up, and make sure the criteria of this drawing the diagram is make sure you draw, that's one for sure, labeling, and it's functional. I mean, the the experiment makes sense. Next, write the chemical equation for reaction 2. I asked Judy.
Judy was don't you do that?
Okay, now Haris.
Okay,
Could you
wait, wait. Bhuvanesh,
yes.
your diagram is wrong, yeah?
Because if heat CO2 will come out here.
Sorry?
If when heat solid R, CO2 will come out right here.
Yeah, so you must go into a lime water. I will take a snapshot and I'll send the diagram in the group. It must be that another way, okay? So it doesn't matter, but what his points are correct. It must be label and it must be a functional diagram. So it's okay, good try, carry on.
Sorry guys about that, my fault.
No, it's okay. We all learn, so don't worry.
Haris, can you help us for chemical equation for reaction 2?
PbCO3 arrow PbO plus CO2.
Right, thank you very much.
Welcome.
So now, the last one, calculation question. They say 2.67 grams of salt oil is heated in the laboratory. Calculate the volume of gas T releases at room condition. So we know our molar mass of solid P is, this is solid R. I think there's a typo in this question. 267 grams per mole. 1 mole of gas occupies 24 decimeter cube at room temperature. So first, we have to find out the number of moles of lead to carbonate. As they mentioned, they've already given us the mass of solid R, so 2.67 grams over 167, so it goes to 0.01 mole. And then we must relate, make sure you guys relate, because that's the most important part. In this picture, I forgot to relate. How you relate is 1 mole of lead carbonate, 1 mole of lead carbonate, ratio of 1 mole of
carbon
CO2.
dioxide.
Yeah, thank you, Chair. Then you get 0.01 mole. It is same as 0.01. So volume of carbon dioxide is 3.01 times 24 equals to 2.24 decimeter cube. So that will be your answer.
Very good. You want to do your quiz?
Yes. Halim, please.
Okay, we'll go to the chat.
Just only 5 questions, guys. It's simple. It should be okay.
What's the quiz number?
4446700. Oh, it sounds like I'm working the Venus.
Eh?
444 Okay, there's Ash, there's Cynthia. Come on, guys. Come on, guys. Let's go, guys. Is everyone in now? Coming? Come on, guys. Simple. Lepak ni. 4446700. This is the code. Let me just put it in the chat. Come on, guys. Join, guys. Come on, guys. Nice. 9 people. Come on, come on, come on.
Nama, maybe we just play with those few who are coming in. Who else is coming in?
Who else want to come? Booth, join a Booth.
Okay, can.
Oh yeah, you didn't. Start up. Wait. Wait. You guys want me?
Do a countdown lah.
That what? 15, 14, 13, 12, 11. I think there's no.
Aman, just go on, just play only.
Okay. Well, Booth, you're not in, right?
I'm not. Okay, I'm joining.
No, there's no.
Okay, tak apa. Just continue, no worries.
Hello?
Yes. Sure, it's almost finishing.
Okay.
7 people has done so far. 7 out of 40.
Why didn't you play the game where everybody plays together?
Well, yeah, that's the same. What? Yeah, I think it's okay. I'm not sure about that. I'm not sure how to do that thing.
Okay, never mind. Okay, are we done yet?
Davis and Snorlax is still doing.
Okay,
Two
teacher
more players. Two more players, and then it should be done. Davis and me.
Should have done the game where everybody plays together.
Yeah, I'm not sure how to do that. Sure.
Should have asked them. It's okay. Good try. Starting, we all start new, start well. Don't worry.
Yeah, can I end the game? There's one more person. Who's me too? Oh, it's me. Is it no?
Me is actually teacher, but I stopped halfway because I don't know where was everybody else.
Okay, so I end game. Okay. Yes.
Now the results, Halim.
Results. First place is Hydrogen Halide. That's me. Second place is Amirul. Third place is Mio. You guys see me in school, you guys will get a free Maggi goreng.
Yeah.
Okay, so Amirul and Mio. Okay.
Okay.
You guys remember this, huh? You guys remember?
I'll write it down.
Next year. Okay.
Amirul and Mio. Okay.
Okay, quick. Thank you very much. Comments for them quickly. They tried, yeah. Say they tried new stuff. And they're happy. They were okay if they made mistakes. So let's comment for them. Okay, good job. Bhuvanesh, good job. Halim, yeah, good job. Good try. Okay, quickly, question number 6. Free Maggie, hiyo.
No, wait, actually, you take me out of the equation and with triple Amirul, Hakim, Mio, and Moon, because those two are the actually top 3. You minus my name. So,
okay,
yeah.
All right, let's go on.
Remind
Question
me.
number 6. Okay, 7, 8, 9, 10, get ready, and also the essays quick. Try not to waste too much time, yeah? Okay, Awis can go quickly.
Alright, so we have an experiment to determine the reactivity series of metals with oxygen. So we have four metals,
Louder, please, Awis.
R and zinc.
Davis, sorry, you can't really hear.
Okay. Hello, test. Can you hear me now?
No.
Okay.
Louder, please. Davis?
Hello.
Okay, go ahead.
Okay. So the first question asks what is the function of potassium manganate 7. So we the experiment is to determine the reactivity series of metals for oxygen. So we must have oxygen, right? So in order to get oxygen